Hello everyone and welcome back to our course. In the previous lecture, we learned how we can calculate the confidence score between two of our channels, Mammoth Interactive and Video Game Reviewer. Next up, we're going to find the confidence or correlation between all of the channels amongst themselves. So I'm going to create a new code cell and get started. I'm going to loop for every viewer in X. I am going to make a sub loop here, or a nested for loop, for every premise in a range of my number of features. So I have number of features. Just make sure we have that variable. Let's see, what did we call this? Number of features. That refers to really just 5. So that comes from our shape. Earlier where we had here x.shape. Okay, we can get from this the number of samples, 100, and number of features, 5. So I'm just going to first grab that just above the loop. So I'm going to say that number of samples, comma, number of features equals x.shape. And you can get that because x.shape is equal to 100, comma, 5 as a pair. So this will return a pair that you can just split into 2 variables. All right, so we want to loop through all of the features of all of the viewers. All right, and then I'm going to create a check if the viewer at the premise is equal to 0. That means we can just make a continue statement, which means that we will just skip this instance of the for loop and just loop through it again. And that's because if there's a 0, that means that the viewer did not like that channel. Next, we're going to record that the premise was watched in another viewership. So I'm going to store here number of occurrences. I am going to create a default dictionary of ints. So for that, I'm going to have to import from collections the default dictionary library here. So that way I can use this function default dictionary. All right, and the reason I want that is because I need to have number of occurrences, and at the key of premise, I'm going to be able to increase its value by 1 if the if statement did not pass as true. If it did pass as true, we'll just skip all the code inside of the for loop and just do the for loop again from the top. All right, then I'm going to loop for every conclusion in a range of my number of features. And I'm going to check if my premise is equal to my conclusion. Then I'm going to continue because we don't need to measure if x is equal to x. So the premise is the first channel and the conclusion is the second channel. For example, in our previous lecture we had here, the premise was Mammoth Interactive and the conclusion was Video Game Reviewer. And those two make up the rule. The rule is that if a viewer likes the premise, they will like the conclusion. All right, so if the premise equals the conclusion, then that means we're just testing the same channel against itself. So there's no point to testing that, so we just continue, which means we'll just go to the next instance of the for loop. But however, if the viewer at the conclusion is equal to 1, this means that the viewer did like the premise and they like the conclusion as well. So that means we have found a correlation, which means that we can increase our valid or rule valid instances. So I can make here times rule valid. The times the rule was valid, I am going to get at the instance of premise and conclusion, and I'm going to assign it to increase by 1 because it means that we found a time that the rule was valid because the premise equaled the conclusion, which means the rule is valid. Now I do have to instantiate that variable, valid or times rule valid. This is going to be a default dictionary again of ints. All right, and next up, what if the viewer liked the premise, but they did not like the conclusion? What if they liked channel 1, but they did not like channel 2? That means we found a time when the rule was invalid. So I'm going to use an else statement, and I'm going to make another variable called times rule invalid, and I'm going to pass in here at the index of the premise, comma, the conclusion. Make sure it's this pair of values as your key. I'm going to increase that by 1. So we do have to make times rule invalid as well. And that's also going to be a default dictionary. Okay, awesome. Okay, so just like that, we've handled all of the rule cases. So we are checking first. If the first channel was not liked, we'll just skip the loop instance. Then we'll check if the premise equals a conclusion. That means that we're just checking against the same channel against itself, which is pointless. Then we're checking if the viewer liked both channels. That's a correlation. If they liked one and not the other, that is a negative correlation. And just like that, we can now get our support and our confidence. So you'll recall from the previous lecture, support is equal to the times rule valid. The confidence is going to then equal a default dictionary of floats, and I have to then calculate the confidence. So I'm going to loop for every premise and conclusion in my times rule valid dot keys. So I'm taking my dictionary and I'm just getting a set of all of its keys. And I'm going to get my confidence dictionary, and at the key of the premise comma conclusion, so the key is a pair of values, take note, I am going to assign it to equal the times rule valid at the premise comma conclusion divided by the number of occurrences. So that is going to be number of occurrences right here, which is our dictionary. So we need the number of occurrences of that premise. Okay, let's break this down. The reason we have to use a pair of values here is because we have what's known as a matrix. We have a table for our confidence because we have all of the channels against each other. For example, I could create a small instance of this. So we have channel 0 compared to channel 1, then we have channel 0 compared to channel 2, then we have 0 compared to channel 3, then we have 0 compared to channel 4. Then we have 1 compared to channel 0, and we have 1 compared to channel 2, we have 1 compared to channel 3, we have 1 compared to channel 4, then we have 2 compared to channel 0, 2 compared to channel 1, 2 compared to channel 3, and 2 compared to channel 4, etc. So that's why we have this table, because we have to compare all the different channels against each other. So that's why we need this matrix here, and that's why we need that pair of values as our key, because we have a multi-dimensional array. We don't just have a list. Then we're getting the number of times the rule was found valid at that exact premise and conclusion pair. So we have a new rule for every single pair of channels. And then we divide that by the number of times that anyone watched that specific first channel. All right, and just like that, we are going to get our confidence. All right, so now let's loop through all of our confidence items. Remember, the confidence is going to store the confidence for every single possible rule pair. So I am going to make a loop to go through all of our results. So for every premise and confidence inside of our confidence, or conclusion rather, for every premise and conclusion. For every premise and conclusion inside of our confidence, I am going to get, first off, my premise name. So let's see, I'm going to get the premise name by grabbing our features, which is the same thing as our channels. I'm just going to look for that. There it is. Our features is just our channel names. And I'm going to get them at the index that we need. So the index is going to be the index of the premise, and that is the name of our premise. So I can call this first channel. Then our second channel, also known as the conclusion, that is going to be the features at the conclusion index. All right, and then I am going to print out the name of the rule. If a viewer watches the first channel, they will also like the second channel. So if a viewer liked, I should say, if a viewer liked channel 0, they will also like channel 1. And I'm going to format into here my first channel as the value to replace the 0 with, and then my second channel as a value to replace the next value with in that string. All right, then I'm going to print out my results. So I'm going to print out my confidence, and I am going to use format again, and I'm going to format in here my confidence array or dictionary, my confidence dictionary at the premise, comma, conclusion pair. Because remember, we're looping through all of our confidence keys and values. Then I'm also going to print out the support, and let's put that in there with the format function. I'm going to grab my support, and let's see, support comes from, okay, this confidence here, the support comes from the value that we need earlier. So let's see, where did we make that? Ah, yes, okay, we created that earlier. Good, okay, so we can use that. And the support here, we need the support at the premise and conclusion. Because remember, our confidence and our support, as well as our conclusion, we need to get those all from our matrix. So that's why we need that pair. It's a two-dimensional array, like a table. All right, and now we can hit run on this code cell, and look at that, we get all of our results. And let me just print a line break in between all of the entries. Okay, great. It'll be a bit easier to read then. And look at this, we have a whole bunch of elements. And I can also print the confidence as a percentage just to make it a bit easier to read. So let me just take this formatting and I'll copy it for my confidence. Then I'll rerun this code cell. And okay, looks like we just need to multiply it by 100 as well. Yes, that's right. I have to format that by multiplying it by 100 as well. Don't forget that part. Then if I rerun this cell, look at this. Now it's a bit easier to read. Okay, let's start with the first rule. The first rule is if a viewer liked Burrowtech, they will also like Video Game Reviewer. The confidence in that was 70%, 69.6. And the support was 32. So there were 32 instances of that. And remember, support is the times that the rule was valid. So out of 100 of our different rows, we found that to occur 32 times. Then our next result, if a viewer liked Video Game Reviewer, they would also like Burrowtech. And the confidence there was 59.3, the support was 32. So very close to what we had earlier, just because those two are the same two channels. Then we had our next pair. We had, if a viewer liked funny cat videos, they will also like Video Game Reviewer. And in that case, we had confidence of 39.7%. So less confidence for sure. And similar for the same pair. If a viewer liked Video Game Reviewer, they will also like funny cat videos. Then we had if a viewer liked Investing 101, they will also like funny cat videos. If a viewer liked Investing 101, they will also like Video Game Reviewer, and so on. So you can see here, some of our rules have higher confidence than others. For example, some of them have a confidence of 61.1%, but some of them have a confidence of only 15%, which is really low. If the confidence is 15, then you might not want to recommend the viewer that channel. So as you can see here, we got quite a few results. So coming up next, we're going to learn how we can easily analyze these results. Because think about it, if you have a huge website that is producing videos and you want to know how to recommend videos to people, well, you have to be able to quickly handle all of the data that comes in, because we only have 100 viewers with only 5 channels. But a real video site would have millions of viewers and perhaps billions of viewers, as well as millions of channels. So coming up next, we're going to learn how we can analyze these results quickly and find out what are the videos that are best to recommend. So we're going to learn how we can find the highest confidence scores quickly. Join me in the next lecture where we will continue our project.